We are literally back in school because hopefully I've got something to tell you with regards to an interesting topic nowadays in architecture, something that I expect you would be facing every day, but hopefully more and more so, which is acoustics. In fact, we are experts in acoustics, and since 2012, we developed a division entirely dedicated to acoustics. I'm Federico Biffi, Export Sales Manager. So for any kind of commercial inquiries, you're going to have my contact, Nicoletta's contact, and of course, we all need to thank Otto Zabola, I hope I pronounced it correctly, and the whole Alex team for organizing this event. So let's start and jump into this presentation. It is going to be a split in basically two sections. The first one is a typical presentations where we're going to go through a little bit of Caimi, which is the company I represent here today. Acoustics 101, just a couple of notions in order to navigate this whole topic of acoustics. And finally, also our take on how to solve acoustic problems, which is snow sound. As I mentioned, a company founded in 1949, a family-run company, right World War II. Basically, the whole country, Italy, has to be rebuilt, and we focused on domestic products, from coffee makers to pots, ashtrays, a lot of domestic accessories. This is what we started with. But the full name of our company is Caimi Brevetti. This second name within the company name means patents. And this is exactly what we've been doing since the beginning of our history. We've been researching and developing new solutions, new ideas, and then we've been patenting them in order to protect these new ideas. In the 90s, we started focusing on collective spaces, offices, restaurants, and that's why, and some of this is still part of our collection, we focused again in accessories and complements like shelving systems, communication systems, coat stands, etc. Moving on, and here we are in the 2010s, 2012 marks a fundamental step in our history because we patented snow sound, which is exactly this material right here. As you are going to appreciate during the presentation today, this can take different shapes, colors, and applications, but the fundamental characteristics of the material itself, they stay the same. It means that no matter where you are going to use it within a project, this is going to absorb sound at an A-class level, and we are going to explore what this means. Finally, we reach the 2018-19 and the recent years of unfortunately, of the pandemic. We started with few products within the snow sound range, and now this collection is a whole division within Caimi with hundreds of different acoustic solutions. So what is sound? Physically, it's the mechanical movement generated by any source which alters the state of rest of air perceived by a receiver. A difficult sentence, but we can easily go down to, you need a source. In most cases, in your project, is going to be someone talking, either directly, like I'm doing myself, or through a microphone. And you need a receiver, so other people receiving the message. In the middle, 99.9% of the time, you're going to have air, but just to let you know, water, for instance, is even a better medium when it comes to the transportation of acoustic signal. The other important aspect of the source is that most of the time in your projects, you're going to have some problems with regards to someone talking or communicating. In reality, you might have situations where the customer has a problem with printers, with air conditioning, with some form of industrial machinery or tooling. And in this case, we're going to have dedicated solutions to this kind of source. This is the state of air pressure without any form of sound wave, the so-called state of rest of air. And basically, the sound wave is a form of energy which is transported through air by state of pressure within the air itself. It becomes super important at this point to understand how to measure an acoustic wave. And there are mainly two units of measures that you are going to encounter. Frequency, with its unit of measurement, hertz, which measures the frequency, which is waves per second. We tend to split the whole frequency spectrum in three different ranges. Between 0 and 500 hertz, you have low frequency. Drum, air conditioning, printer, deep male voices. Between 500 hertz and 2000 hertz, you have the mid frequencies, which tends to be human voice. So it is super important in most projects. 500 hertz being male voices, 200 hertz being kids and women's voices. Above 2000 hertz, we have violin, whistling, and shrill voices. The second unit of measurement that you're going to encounter, which is actually much more familiar to all of us, is decibel. What is it? It is used to measure sound pressure level, technically, which is called in everyday life way, the volume of sound. So here it is important to understand that each mix of frequency and decibel, so volume, creates a particular state which can be audible or not to the human ear. For example, between 0 and 30 decibels, we are still in the region of low sounds with low volume. No problem at all here. Talking, like regular talking from all of us, stands at between 40 and 50 decibels. As you probably know, this is an exponential scale. So the higher you go, it means that the increments are multiplicative. At 55 decibels, you encounter a vacuum cleaner, for example. A regular office is going to have 60 decibels. And then we go up and up, traffic at 70 decibels, 90 decibels a truck, and then we enter a range which becomes dangerous for the human ear. 100, 120 decibels and beyond can hurt physically your ears. And this is how we mix together frequency, which you can appreciate horizontally, and volume, which you can appreciate vertically. As you can see, the speech range in reality is a small area within this chart. A bigger area is the music field, which actually has bigger frequency and also eventually higher volumes. In general, the audible range is even bigger, but we have huge regions close to the bottom left corner where, because of low frequency and or low decibel, we're not going to be able to hear anything, but we also have a whole region above a certain decibel level and or frequency where we pass the threshold of pain. It means that we're going to be physically hurt if hearing sounds beyond that level. This is the case of an open field. It means you are outdoor and you basically hear sound directly. In a place like this one, yes, we are going to have a direct wave. So no reflections between source and receiver. Just like in outdoor, the sound wave going from my mouth to your ear. But we are also going to have first reflections. It means that you're going to have one bounce off the ceiling or the wall or even the floor from my mouth to your ear. In reality, sound travels at 340 meters per second, and it's going to have multiple reflections off different surfaces, walls, ceiling, and floor. So it's going to keep traveling around the room and finally reaching the destination, which is your ear. But this is going to cause reverberation. And this is exactly the topic we are going to cover today. The effect of the propagation of sound in closed environment causes reverberation. This is just an example to show how reverberation has a different impact depending on the architectural situation of a given space. In this case, we studied round arches, segmental arches, and ogival or Gothic arches. As you can appreciate, in the first and the third example, round and ogival arches, the architecture, the vault itself, is going to concentrate reverberation in the middle of the room. While with the segmental arches, or the lower arch, reverberation is going to be concentrated to the side of the room. This is a project we did in Assisi. You're going to hear a man, he's speaking in Italian, but nevertheless, you are going to hear a lot of reverberation, and you're also going to hear in the next slide how we solved the problem with our acoustic products.
I pannelli sdossando non sono stati ancora montati e si può notare il tempo di schermo molto alto.
So I'm a native Italian speaker, and I can assure you that it's super complicated to understand what this guy is saying because of the amount of reverberation of noise generated by this architecture. Specifically here we have reflecting surfaces on the walls, and even worse, we have a vault. Whenever you have a vaulted ceiling, please be super cautious because it tends to make the acoustic situation even worse. And this is how we solved it.
Allora, ci troviamo nuovamente nell'aula 2 dell'Università di Perugia a Palazzo Bernabei in Assisi.
So again, this is exactly the goal of our acoustic intervention. In this case, this is a university room where communication is key, basically. You have a teacher and you have people trying to learn something. In the previous situation, it was impossible to communicate. Here, we got rid of all the background noise, and this is the result. Talking about the impact of sound, and specifically bad acoustics on human beings, we studied different situations where this is going to be fundamental. When it comes to an open space office, what we want to achieve with an acoustic intervention is privacy, intelligibility, which is a tough word in English, but it's super easy to understand. It's actually the possibility to understand each single word in a given sentence. So it's improved communication, concentration, and efficiency. At the same time, we want to get rid of ground noise, ear discomfort, incomprehension, absenteeism, and stress. Already, we understand that eliminating, or even better, containing stress, incomprehension, ear discomfort has an impact on the performance of workers, of all of us. And it is a common experience. Working in a chaotic, crowded space with no acoustic privacy leads to tough and difficult work. And this is my favorite situation, restaurants. As you can see, I'm a big man, so I do love restaurants. And it's actually super common sense and something that we have experienced, all of us. Nowadays, good food and good service is just the starting point. We go to restaurants, to cafes, in order to spend time with friends, with family. We want to talk, we want to communicate. Hence, acoustics becomes fundamental for a working space like this one. We conducted, actually there's already a good literature regarding this, that specifically in restaurants, acoustics is one of the best investment for the owner, because good acoustics leads to longer stays within the restaurant itself. And longer stays within the restaurant means an extra beer, an extra spirit, an extra liquor, a dessert. It means that people getting here in a proper space, acoustically treated, they're not going to stop at the main course. They're going to enjoy their time spending more. So in restaurant, acoustics is one of the best investment an owner can do. So this is exactly what we developed and we patented. This is the heart of the technology. One step back. When it comes to sound absorption, so the reduction of reverberation time, it is relatively easy to absorb sound at a given frequency, but only at that frequency. We call it a brilliant intuition because it is a brilliant intuition. Our technology is a panel, 100% polyester, but with variable density inside. It means that at the core, it is softer, and moving to the edge of the panel, it becomes harder and harder. This is the brilliant intuition. This makes it possible for the panel to absorb sound and have outstanding acoustic performance throughout the whole spectrum of frequencies. And because of this, we researched and developed the right composition of the panel in order to achieve Class A for sound absorption according to UNI EN ISO 11654, which is the international standard for testing sound absorbing element. We do this in our reverberation chamber because we have one built inside our acoustic laboratory, but of course, because of the conflict of interest, we also have a third party certifying the acoustic performance of our materials. And this is how the acoustic performance of our panel looks like. Here you have a chart between 0 and 500 Hertz, which is the blue region you have in the chart, which is basically low frequencies. And even within this range, we reach up to 55% of sound absorption. This is outstanding and already incredible because in acoustics, low frequencies are the hardest to get absorbed. It's a type of sound wave that it's super difficult to absorb. Reaching 55% in this range is already unusual. We designed our panel in order to be super effective in the human voice range between 500 and 2000 Hertz. Specifically, we peak at 94% of sound absorption right in the middle of this region at 1250 Hertz. And then, by design, the green region, we have a decreasing line because high frequencies are easily absorbed by anything, basically. Even ourselves, as human beings, we absorb well at high frequency. Hence, we didn't want to have a technology overkilling the high frequencies. Here are some of the unique selling points of our design and of our technology. We already mentioned the fact that it's an A-class product, the highest you can get on the market, but it is also completely double-sided. Our panels, in fact, has two faces which are symmetrical. It means that you can install it on a wall or directly on a ceiling. That's a given. But when placed in the middle of the room, like a partition, it's going to have an overperformance because both sides are working. Even more so, our panels, as you are appreciating from the samples, is actually thermically molded. It means that it is self-supporting and you do not need any added frame in order to keep it stable. It means that you're saving money when it comes to the profiles, and also you do not have reflective surfaces around the panel itself. So far, I've been talking about panels. This is one of the technologies that we have patented, but in reality, there is a second option because we also patented and developed sound-absorbing fabrics. By this, I mean just textiles. This can be used as finished products that we offer, but it is also an opportunity for you because thanks to this kind of acoustic product, which is sold in rolls as a raw material, you can make curtains, blinds, and shades. It is going to look like something like this. In this case, we're talking about an audio and music environment. Each of this space has been treated using different products. In the Radio Dynamo example in Milan, we have flap panels, those geometries you have on the wall. In case of Consortium, Perugia, we have fabrics hanging from the ceiling. In case of the home theater in the United States, we have Mitesco panels suspended from the ceiling. This is the message. In case you have an acoustic problem, there is a good chance that freestanding, wall or ceiling, we are going to have the right solution. The same applies to canteens. There are many ways from an aesthetical point of view of how you can intervene. Sometimes professionals like you choose a simple rectangular panel. You could install something here, white on white against the ceiling. The aesthetic impact is minimal, but you get the acoustic value. Other times, your colleagues around the world decided to go for impactful applications of the sound absorbing element. It's the case of Gruppi Generali, the example top left, where they used fill flaps. This is an acoustic panel which resembles a little bit a bird flying through this space. Or again with flap, the Arnaldo Mondadori Editore, one of the biggest editors in Italy, where they went again with flaps, but in this case playing with color, a strong yellow against the gray ceiling. Conference and meeting rooms are some of the most important environments for us business-wise, because as we saw before, you tend to want extremely good acoustics in a place dedicated to communication. And this is some of the examples. I really like the International Bank of Moscow example because it introduces one of the situations where we are working really well, which is exposed ceilings. I'm sure this is something familiar for all of you, and we are working with situations where this solution is used more and more. And it is something that we can also work with when it comes to reducing reverberation, given the fact that you have a hard surface and no drop ceiling. Education and schools. As we saw before, we want our kids and our students to learn something. And in order to do this, they need to hear well. And this is what we've been doing in some schools and universities around the world. Home is a residual market for us. We have niche applications, especially for home theaters or spaces dedicated to hearing. And still it is becoming more and more important because it improves the acoustics, but at the same time gives you a chance to create a decoration, especially if using some of the more decorative pieces we have available. Finally, we reach offices and call center, which is still most of our core business is done in offices and call centers because, again, by definition, you want to have proper communication, hence proper acoustics. It can be done with a straightforward approach. We have workstation panels that can be installed directly, or you can create trees up in the air like they did in Edison, Milano. So we grant you the acoustic performance, but you are going to be the one giving shape to the acoustic intervention. So we like to think about acoustics as a full package. We want the technical background, and hopefully we showed you today that thanks to the open lab we built, we are conducting some of the most advanced research and development in this field. It is a full package because we also want to have some of the best shapes, colors, and designs when it comes to our technology. And as you saw, we've been collaborating both with important and famous names in architecture and design, but also with young talents. The last piece of this full package is the service, which is delivered through the website. In case you're interested, please contact Alex in order to make sure that your acoustic treatment is going to be raised at a professional level. Because sometimes I see customers throwing some supposedly acoustic material on the wall or as a couch, pretending this is a professional acoustic treatment. It is not. We have a scientific approach, and we do this through the acoustic analysis. It is not going to take away a lot of your time. The algorithm behind this application is patented and it is super complicated, but it is made user-friendly in order to be straightforward. In any case, both myself, Nicoletta, and the Alex team is available to make these calculations for you. We are going to need the dimension of your project, the height of the ceiling, and the intended use. This is important. As we saw, a gym, an office, a restaurant, and a church, they have different needs when it comes to acoustics. Let's make it an office. And we're also going to need the materials you're going to use in this project. As we saw before, it goes down to the alpha value that we've been learning before. And this is what you are going to get. This is what we call the pre-intervention reverberation time. It means that inside this room with these dimensions and characteristics, you are going to have this reverberation time. How to read it? For example, here at 1000 Hertz, which is again in the middle of the human voice range, you are going to have close to 2.5 seconds of reverberation time. In fact, you have frequency here and reverberation time in seconds. So basically, how long sound keeps traveling inside the room after I stop talking. So this is a situation as it is, and here you have the solution. You're going to select your technology. In this case, I'm going to make an example with snow sound. I want to use baffle panels, so panels hanging from the ceiling. And this is what you are getting. But it's not just a calculation like this. You are going to visualize and explain this to your customer. In fact, we generated two new lines, the silver line and the gold one. The silver, we consider this a good acoustic intervention, while the gold one is basically state-of-the-art. It means that after installing this number of panels in this room, you are going to drop your reverberation time from 2.5 seconds, close to at 1000 Hertz, down to around 1 second. All these dots and these lines are calculated by our algorithm based on the dimension of the room, but also the purpose of the room, in this case an office, as present in the scientific literature. This is a powerful tool because it allows you to mix different products. Let's say that you're fine with some baffles hanging from the ceiling, but you also want to use something on the floor, like a freestanding element. You simply enter a panel, snow sound, once again. I want to use Metesco divider, which is a partition, dimension, a partition of 4 panels one-sided. In this case, I'm telling the software that I'm going to use 8 compositions like this one. As you can appreciate, it already recalculated the number of baffles in the first line. And once again, it shows how this is going to have an impact on your project. At the end of the day, what you are going to get is a PDF, which can be printed through this button, which is going to generate a PDF, a summary of everything you calculated. So basically, I'm basically done here. The final message for you today is, in case you have an acoustic problem, in case you have something to do with sound in general, you have a reliable partner in Alex and ourselves, Caimi, which is going to provide you with many different solutions, but at the end of the day, solving the acoustic problem you have in a good-looking way. And I think this is the goal for most of us and for most of you as professionals. So thank you again for the time you dedicated us today, and I hope you're going to be contacting us soon for some collaborations.